Hello, everybody. Welcome to the session. My name is Jack. I'm representing QCT Quanta. Today, I'm going to talk about enabling AI from cloud to edge. So this just get started, right? Today's contents will be covering both, from a hardware vendor side to solution providers. We'll be talking about now hardware design surrounding the modular design, especially on DC-MHS for the OCP community. And another thing is we'll be talking about Nvidia's MGX architecture that we have been working with Nvidia for just over a year till now, and we have some good progress there. And with that, we'll also touch base on our end-to-end solutions from cloud to edge, and how we have the ubiquitous AI everywhere in our system, and why and how we have the liquid cooling also support all these AI projects as well. And I think the most important thing is that we are also the system integrator as a solution provider, being able to work with Intel on all the workload optimizations. We'll be able to provide more performance with less of the hardware investments. So this is the overall total solutions from all the data centers, including the compute server, accelerated server, storage server, all the way to the edge that we have the short depth chassis, private 5G, and with our RU design to provide completely end-to-end solutions with a stable, award-winning private 5G solutions. What is important thing is that we put all the AI flavors inside to make sure it's ready for the PCI type of the GPU acceleration. Not only that, we also have these dedicated systems to be able to support all the AI needs, including the A-Way GPU as well as the GH200 system. And more importantly, this all are liquid cooling ready with our CoolRack solutions. Last year, we were the only one to do the live demo on our cooling rack. This year, we increased from the 45 kilowatts to 85 kilowatts in our booth. And next year, we'll be also introducing a much higher thermal capacity as well. Being able to do that is, we thank to all the our ecosystem partner. We have been gone a long way with Intel, and also we are starting from the first generation with AMD on their Naples system, and also we work with Nvidia on their very first DGX1, the one that do all the generative AI right now, and also the other important components from generations over generations. We are working very closely with them, and this is how we can deliver a very profound product portfolio to our customers. So today's major topic is about DC-MHS, right? So we have HBM SKU, HBM to have two different flavors. One is FLW, the one is MDNO, as well as being able to support MXIO for IO connectivity, complying with the MPASI for the sideband signals, also the PIC, as well as the MCRPS. We know that MCRPS power supply is not ready from the vendor side, but at least from the system perspective, we are ready to adopt that. So these two systems, if you are attending this morning's Zambo's keynotes in the morning, you should have seen these boards on stage. And this is also manufactured by Quanta QCT. And they will be supporting next generation, fifth generations Intel's P-core and E-core based CPU platform, right? So this is FLW compliance, starting from its dimensions. Everything's not only the dimension, but also the outline is strictly follow the FLW. And as well as, we love OCP NIC card for its better serviceability. And we also the first one to introduce ROM BMC as a BMC module. DCSM 1.0 was introducing with our Severapis platform as well as the Genoa platform. Now we are on to the DCSM 2.0, as well as MCRPS power supply, and also the XIO for the PCI riser. Here we put our engineering expertise to the flexible zone to have the best routing for the CPU UPI, as well as the VR for the power, and also the DDR for DDR5 to the higher frequency, like Sambo mentioned this morning. This motherboard is not only from the baseboard perspective being DC-MHS compliance, but the most important thing is make it compatible with different kind of system design, including both 1U and 2U system using the same motherboard, as well as supporting both air and liquid cooling. So from 1U 2U motherboard, 1U 2U system normally have different considerations, including the PCI cable routing, high-speed signal routing, risers assembly, and also the PCI slots allocation to the front and the back for both storage and NIC I/O. Being able to accommodate both is not easy, but we managed to do that. To make it more complicated is the thermal solutions. To support air cooling, we need to make sure the airflow is very straightforward without any blocking on particular area. However, for the liquid cooling, we need to make sure that we have the routing space for the liquid pipes, so you will not accidentally damage any components on the motherboard or have any leakage inside our system. So make sure the interoperability of the HBM for different platform is important, so we can enhance our modularity design. And ideally, with more leverage between the different design, we can attain the economy of scale and further to drive the cost down, right? More importantly is that we can, being able to support the sustainability goal for not only ourselves, for the embodied carbon footprint, but also for our customers, right? Another example is our DNO type of motherboard. So here you can see with a single motherboard design, we have derivative chassis design for both 1U and 2U, just like I said with the FLW, as well as the edge server, and also the multi-node server. And very interesting is that we have another MGX system, which is, we can say the MDO-like, because it's not fully compliant, but it's also the modular design that we are very proud of in this design that we work with Nvidia together. Again, 1U, 2U, edge server, leverage the same motherboard, and also multi-node system. These are the 1U, 2U 2-node, 2U 4-node, front access, rear access. We can all leverage the same motherboard, right? With that, I want to bring up one particular product. This is the one that work with Nvidia. And this is the S74G-2U, our MGX system to support the GH200 module. Although this is not like DC-MHS compliance, but we know that Nvidia is working closely with the community, try to make it a part of the community standards as well. So I will not go into the details of this one. If you're interested, you can contact with us. Go to our booth. We can do the product introduction for you. But what I'm trying to do today is to let you know how we leverage the modular design in this system. So this is the top view of our system, and you can see it divided into bay design. So the green one, we call it Type B bay. The yellow one, we call it Type C bay. Both front and rear are the same width, so they are interchangeable. So this is a rear access system, a very traditional EI rack system. And we can change it to the front access system just like this, leveraging a lot of stuff. And we can further change it to the 1U 2-node system, also leverage the same building blocks. So we are in the first generation of building this architecture with a lot of building blocks in the place. And once we have more building blocks, we'll be able to come up with a new design more easily. And not only that, these are the location of the motherboard. They are the same dimension, the same leverage motherboard. As well as the heatsink, we leverage the same heatsink as well, right? So this design can give us more flexibility, ready for future. We know both Intel, AMD, and also Nvidia, and a lot of silicon vendors, they are introducing those new silicons more frequently right now. So it's really important that we can come up with the architectures that can be future-proof, as well as a modular design to have the best leveraged. Right. So again, this is the FLW HBM. We have our future P-core, E-core ready motherboard. We have our MDL HBM motherboard, being able to support 1U, 2U server, the same motherboard, and also the MDL HBM system, being able to support 1U, 2U motherboard, 1U, 2U system, multi-node server, edge server as well as probably you can put the compute nodes into MGX or vice versa. So with that, what I'd like to end with this one. So we try to empower more with the modular design. We know that we don't have enough resources to create everything, and we don't want to reinvent the wheels every time when we have new products coming out. So having the MFLW, we will be support 1U, 2U, air cooling, liquid cooling for the best design efficiency. MDL HBM, we want to create a broader type of range with different kind of system design, leverage the same motherboard. MGX architecture, we are very exciting that we're working with Nvidia on this one. Nvidia is committing to this. We are committing to this. We are driving the system partners ecosystem to adopt this kind of architecture, so they can have a better scalability and also the flexibility for the future GPU products. So again, Quanta, we consider this is not only a hardware system provider, but also the solution provider. Being able to have our resources spent more wisely on this kind of modular design and being ready to be future-proof, we will be able to support more resources on the solutions creations and bring more value proposition for our customers together. Right. So that's about all the slide I have today. Our booth is right here. We are looking right here. So if you go away to the end of these directions, you will be able to see all the systems that I just introduced. Any questions? No? All right. So then thank you very much for your for coming here. Yeah, and looking forward to see you in our booth. Thank you.